I'm Elouise and I'm part of the maths team here at the University of Wolverhampton. And in this video, we're going to go through some essential maths that you'll need for your physics course. We'll go through vectors, rearranging equations, and degrees and radians. So, vectors are quantities that have a size and a direction. They can be split into components or they can be combined to get a resultant, which is the overall effect of the vectors. So if we had a question like this, where a hot air balloon rises vertically upwards at a velocity of 0.5 meters per second, and a horizontal wind pushes at it at a velocity of 2 meters per second, and we wanted to find the resultant velocity and angle to the horizontal of its ascent, that's when we'd use vectors. So I'd always recommend drawing a diagram whenever you're faced with any questions such as these. So I've got my arrow for the horizontal wind, and I've got my arrow for the vertically upwards velocity. And then the resultant will go from the tip of one arrow to the other. And that's what we need to find. So we've got our good old friend Pythagoras, and we can find x because it's a right angled triangle and we've got two sides. So a squared plus b squared equals c squared, where c squared is the hypotenuse, which is the long slanty side of the triangle. So 2 squared plus 0.5 squared equals c squared, and then we take the square root, and there we have it. And if we wanted to find the angle to the horizontal of the ascent, where the horizontal is the line here, and then y is that angle, we can use SOHCAHTOA. If you need any help using SOHCAHTOA, we do have a maths video on this. So we have the opposite and the adjacent of the angle, so we use tan. So we have tan of y is 0.5 over 2. Then you use the inverse tan and you find that y is 14 degrees. Now we'll go into this a little bit later, but make sure that you're using either degrees or radians depending on what the question's asking for. So here's another type of vector question that you could come across. A ball is kicked at 18 meters per second at an angle of 42 degrees above the horizontal, and we want to calculate the vertical component of its velocity and the horizontal component of its velocity. So again, big fan of drawing a diagram. The horizontal component and the vertical component makes this into a nice right-angled triangle. Okay, so when we want to calculate the horizontal, we have the angle, the hypotenuse, and the adjacent. So we use cos. And when we want to find out the vertical, we have the opposite and the hypotenuse and the angle, so we use sine. So rearranging equations. Say we had this, r equals v over I, and we wanted to make I the subject, which means we want it in the form of I equals. How would we do that? Well, we want to get I on its own because we want I equals. But at the moment, I is being divided by, which looks a bit messy and scary. So what I'm going to do is I'm going to undo it. So if we're dividing by I, I'm going to multiply both sides by I. Now make sure that whatever you do to one side of an equation, you do to the other side of an equation. Think of it as balancing scales. If you divide by 5 on one side, you need to divide by 5 on the other side. So we're multiplying by I. On the left-hand side, we have r times I, and on the right-hand side, we have v times I divided by I. Now, if we multiply by a number and then divide by that number, overall, we're doing nothing. So let's pretend our v was 5 and our I was 10. We're doing 5 times 10 and then dividing by 10. Well, that's just 5. So we can get rid of the i's altogether on that side of the equation, which is what we wanted. And now we're one step closer to having I on its own. We have Ri equals V. Well, the thing that's in the way now is we have an R and we don't want an R, we want an I equals. So how do we get rid of a multiply by r? Well, we divide by r. So if we divide both sides by r, we end up getting v over r. So our answer is I equals v over r. Now, rearranging equations can take a lot of practice, so just keep trying. But here are some good rules. If you have something in the way that's a plus, such as like a +5, take away 5. Or if you have a takeaway, you add. If you have a multiply, you undo it with a divide. And if you have a divide, you undo it with a multiply. The opposite of squared is a square root. And to undo a square root, you square. For a cube, you cube root. For a cube root, you cube. And then the bottom one are natural logs and e. So they may look a bit scary, but we do go over them in one of the chemistry videos if you'd like to check that out. So, degrees and radians. You're probably very familiar with degrees for measuring angles, and we know that in a circle there are 360 degrees. But in a circle there are also 2 pi radians, which means that in half of the circle there is 180 degrees or pi radians. But what if we had a bit of a weird one? What if we had 75 degrees and we wanted to find out how many radians that was? Well, let's use our algebra skills again. So if 360 degrees is equal to 2 pi radians, well, let's find out what 1 degree is before we find out what 75 degrees is. So I'm going to divide both sides by 360. And we get that 1 degree is 2 pi over 360 radians. And now because we want to know what 75 degrees is, we multiply both sides by 75. And when we put that into our calculator, we get 1.3 radians. So again, it's really, really important when you're doing anything with angles to make sure that your calculator is in the correct form, degrees or radians, because they're very different. So that wraps up this video on Essential Maths for Physics. Hopefully it helped, and check out the other videos that we have in the series.